Alright guys, in this video we're going to be looking at deviations from the ideal gas law. Remember, ideal gases mean those particles are all the same, like every gas particle, no matter what they are, they behave ideal, which means they don't have interactions with them, they have perfect elastic collisions, which means the deviation is due to intermolecular forces. The stronger those intermolecular forces are, the more they deviate from being ideal gases. So in these two multiple choice questions, we're going to be looking for something that deals with intermolecular forces. So in this first question, we've got a table, and we've got four different gases in four containers that are all identical, and they're rigid. But we notice that there is a deviation in pressure with SO2 compared to the deviation of these other three, which are behaving almost identical. So the best explanation for the lower pressure in container 4 is that SO2 molecules have a larger average speed than the other gases. That is not dealing with intermolecular forces. They occupy a larger portion of the container volume than the other three gases. That is not intermolecular forces. C, SO2 has a stronger intermolecular attraction than the other three gases. There is the right answer, and contains pi bonds will not be the right answer. Remember, when it comes to deviating from intermolecular force or from ideal, it is due to IMFs. Okay, those attraction forces is what cause the pressures to drop, like we see here. These were two. Those attraction forces bring the pressure down. Okay, looking at another question, which of the following best explains the pressure of a sample CH4 is closer to the pressure predicted by the ideal gas law than NH3? So CH4 is more ideal than NH3. That must mean that NH3 is going to have stronger attractive forces than CH4. So we'll see if there's an answer choice that goes along with that. That's true. NH3 molecules are polar, while CH4 molecules are not, and the greater attractions between NH3 molecules cause the molecules to collide with the walls of the container with less force. That sure makes sense to me, but we'll look at the other ones, but that is definitely probably going to be the right answer. NH3 molecules have a greater molar mass than CH4 molecules, so the NH3 molecules collide with the wall of the container with more force. Okay, no, we are looking for something with intermolecular forces, and that's what causes deviations between ideal and non-ideal gases. CH4 molecules have more hydrogen atoms than NH3 molecules, so CH4 molecules have more hydrogen bonding and greater intermolecular forces. Now, here's one that's interesting. They are bringing up intermolecular forces, which is a cause for deviation in ideal gases. But is it a true statement? Can CH4 do hydrogen bonding? And the answer is no. CH4 cannot do hydrogen bonding. NH3 can, but they're trying to say that CH4 has more hydrogen bonding, and that's what caused the deviation. So C is just not true. In reality, NH3 does hydrogen bonding, so that should cause the deviation for those molecules, but not CH4. So they got it backwards, and they're trying to trick you. So they're going to trick you and try to do an intermolecular forces reason, but it's not true. CH4 molecules are larger than NH3 molecules, so the actual CH4 molecules take up a significant portion of the volume of the gas. They are nearly the same size, so no, and we are looking for an answer for intermolecular forces, so it is definitely A.